Well, welcome everyone to another week of In Rhythm's Lightning Talks. For those of you who do not know me, my name is Jen Crawford, and I have the pleasure of co-hosting this space with all of our practice area consultants here at In Rhythm. In Rhythm's Lightning Talks, they happen on a weekly basis at 5:15 p.m. Eastern. And again, as I mentioned, it is our opportunity for our practice area consultants to teach back to the In Rhythm community, as well as everyone on YouTube and as well as LinkedIn. This week, I have the pleasure of co-hosting this space with Kane Ford. He is going to be talking about building better intelligence, tips for AI design. This is really cool. I'm really, really excited. So with that being said, I'm going to hand it over to you, Kane.
Awesome, thanks. Well, first I want to say thank you to everyone who's taking the time to check out this lightning talk. This talk is a little design heavy, but it's not so much technical. Really, my goal here is to make this content understandable to anyone. So designers, developers who have worked on AI projects in the past might be familiar with a lot of this, bear with me. But really, the goal of this is to have all of you walk away from this maybe thinking about AI a little differently than you did before. And as long as that happens, then I consider this a success. So I have been having audio problems. I'm going to go ahead and actually stop my video right here once I start going through the slides. I apologize. But I guess first, let's start with introductions. So my name's Kane. I'm a designer here at In Rhythm. I'm currently doing enterprise UX work over at Amex. I'm also a design instructor at the University of Miami here in sunny Florida where I live. Most of my experience designing for and with AI has been in the retail space, especially in fashion and beauty. So lots of e-commerce and marketing, lots of projects involving natural language search, visual search, product discovery, personalization, recommendations, fit and sizing, outfitting, smart bundling. I mean, the amount of retail applications for AI is insane. So with that said, I just want to take a moment to make it clear that I am by no means an expert in AI. I'm just a passionate designer who has been reading Turing and Kurzweil since he was a kid. And one thing that I always found was funny was that, as UX and product designers, we are always told to, stick up for the user, to be the user's voice. And very seldom do we consider, that someone might need to be the machine's voice. So today I'm hoping that I can maybe change that a little and hopefully you can at least walk away from this with a different perspective on what AI means and how to design for AI and its complexities. So to get to that point, I want to first briefly touch on kind of what AI is and how it works. This will lay the foundation for hopefully a discussion about how we can shift our thinking and our approach to AI design that can help maximize the improvement of our users' experience when they interact with the system. And I mean, at the end of the day, that's why we're all here, right? So looking at what AI is. So this is a pretty difficult question. It's difficult to define because honestly, there's not one clear definition, and it depends on who you're asking, what professional field they're in. There's all sorts of different types of AI, AI used for all sorts of different things. But there's one thing for sure, is that AI is literally everywhere we look in this day and age. It permeates and saturates the world around us, both physical and digital. It helps us with countless tasks daily, oftentimes going completely unnoticed by most of us. So with that in mind, I kind of want to start out by defining AI very generally with a very loose definition. I happen to like IBM's definition. Artificial intelligence leverages computers and machines to mimic the problem-solving and decision-making capabilities of the human mind. So first, as a side note, I just want to say that I'm a huge fan and practitioner of IBM's flavor of enterprise design thinking. I love their work in the AI space. I just wanted to shout out to them. They are obviously industry leaders. Deep Blue is kind of a household name at this point. So I would highly suggest leveraging them as a resource if you want to learn more on your own about AI. They actually have a really cool AI Essentials for Enterprise Design Thinking certification that's really fun and it teaches you a lot. But more importantly, right here, I want to point out the bit about mimicking the human mind. That's a really important concept to understand, and it's going to become more important in a few moments here. First, I want to take a look, though, at the different types of AI. So there are, of course, many ways to classify AI. So you might have heard or read about narrow or general or super intelligences, which are pretty standard descriptors for types of AI, and it depends on their scope and goals, purpose, and what they do and how they do it. But for our purposes today, we are going to classify AI kind of based on their level of complexity. So at the very bottom of the stack, basically, we have what's called reactive machines. So reactive machines just make basic inferences on data that's in front of them, right? So you present them with something to look at, and they follow a list of rules and basically match rules to a scenario and come up with a prediction or solution or what have you. Now, these are incredibly simple. I guess a really good example of what you may not expect to be a reactive machine. If you've ever watched like a TV show or a movie where they have some kind of like facial ID or facial recognition going on the screen, and there's a box drawn around that face. So that's an example of a reactive machine, right? So it's taking real-time data for that picture of the face, and it's matching it against rules. And it's saying, okay, it's got two blobs in this area. This is probably eyes. This is starting to look like a face. Let's draw a box around it. So really at this point, though, the machine is only as smart as the rules that you put into it, which brings us to our next level of complexity, where in addition to kind of thinking live about what it's seeing in front of it, the AI or the machine or the system also has the ability to store that data. And so what emerges from this is learning. So the AI is able to take a look at past data, past predictions, and use it to improve and make better future predictions in its model. So that is something that we can currently do pretty well. And above that, the next level of complexity, which I'll just briefly touch on here, is theory of mind, which at this level of complexity, AI begins to interact with thought and emotion. So this is something that we're just recently starting to really gain grounding. So 2019, 2020, we made a lot of headway in terms of emotional AI. We're still not quite there yet. But if you take a look at the next level of complexity, self-aware AI, I mean, we're nowhere near that level. This is where AI recognizes and negotiates for its own existence, right? So we're right here with limited memory, AI that can learn. We're working on theory of mind right now, but in all honesty, the concept of AI that most people have, kind of that like sci-fi, computers thinking for themselves. Most researchers, scientists, they think that this is definitely something that we'll achieve. We're just nowhere near, achieving that anytime soon. So for our purposes, I really want to focus on this limited memory AI, this AI that learns. And so remember, limited memory means that the AI is capable to store and reference previous data, previous predictions, and include it in whatever calculations or algorithms or rule sets or however it's generating its predictions, to use that old data to continuously get closer and closer to perfection, really. So there's two ways that we can do this. So the first is manual. So that means having a team continuously training a model, on new data, thinking back to the concept of, treating AI almost as a person, as a, almost like a copy of a human mind. As children, we have a tendency to, go through various stages of learning, right? And AI kind of follows that as well. And the more that an AI matures, and especially if it's designed properly, you can actually build the AI environment in a way that models are automatically and continuously training themselves. So this is kind of like where a child learns to start reading, or they begin to be able to communicate better, right? That mental acuity is heightened. They're able to take in new information without having it spoon-fed to them. And so again, when we think about the parallels to a child learning, it can be really useful to kind of think about engaging with AI not as, using it as a tool, but also, thinking about the concept of teaching the AI through the experience that you're building. So this means helping them, recognize successes and failures during the feedback stage. So, thinking about this second point here, building the AI environment in a way that models are automatically trained. This is arguably the one that is far more easier for us as designers to help with. Typically what we would see in what we would call an active learning cycle is something like starting an A off with some training data that acts kind of like a seed, and the model would make some predictions based on whatever data it has. And then the system would gather feedback on those predictions from a user or from its environment. And that feedback gets stored and calculated and fed back into that training data so that the process can repeat. And so as designers, the most, and in some cases, perhaps the only influence that we can have during this process, during the feedback phase, is when we are consciously building a system that can capture user feedback and learn from it. But as AI becomes more complex, so does the design. So the first complexity that we have to face here is really the very nature of learning itself. So AI is a technology that tries to predict outcomes by learning from data, right? And this process, remember, is designed to mimic, human cognitive processes. So that means as designers, in a way, it's our job to help shape how AI understands the world around it, almost in the same way that we would with children. So, as a child learns through its mistakes, so does an AI. And so that means that the interactions between humans and artificial intelligences need to be designed very purposefully in both directions, right? Humans need to be able to teach the AI how to do better next time, while at the same time, those humans also need to learn to trust the AI's decision. And that only happens when communication flows in both ways. But that trust question, that opens up a whole new complexity, and that's overtrust. Oops. So people in general just aren't very good at understanding statistics and predictions, right? So what often winds up happening is something that we call automation bias. And what it is really is it's an excessive amount of trust in a closed system simply because they're known to be smart or intelligent. This is a phenomenon that's often seen when using GPS to navigate. So, the recommended routes, most people trust those, and that can actually, trust those without question, I should say. And those can actually create problematic situations when combined with like inaccurate predictions or recommendations. So there are hundreds and hundreds of stories just like these all over Google. I've read sources stating that GPS can cause upwards of 200,000 accidents a year worldwide. Of course, that's for a variety of reasons, ranging from distracted drivers to inaccurate maps. But imagine if we could design these solutions more responsibly. And certainly, without doubt, the teams at places like Google and Waze are doing exactly that. But if any of you are familiar with The Office, you might be familiar with the scene where Michael Scott drives into a lake because he blindly trusts the machine. And that machine happened to be wrong. And so, by extension, Michael Scott was wrong. And we all know how that scene turned out, and it was hilarious. But it brings up a really good point in that it's crucial to make room in your design to help the user understand how the AI actually works, to cultivate just the right amount of trust and buy-in, not to the point where the person is just blindly following whatever the AI says. And that's just with navigation. So imagine, what if the AI was diagnosing serious illness? So we begin to see kind of real world consequences here to our AI design and how we're building it. So those kinds of inaccurate predictions create the third complexity that we face really when designing for AI. So today it's pretty easy to build an AI model with an accuracy of 80, 90%, but really achieving that last mile is a totally different story. It requires more money, more data, more time, more effort, more expertise. And so really what you wind up getting is a limit of diminishing returns after a certain point. You're never going to have your AI be fully and completely perfect. So what this means is that there's always going to be a chance that a prediction will be wrong. And so it becomes really important to design while accounting for that when we're considering the user's trust. So for example, using the GPS idea, a navigation system could sound an alarm or indicate that it's not sure about a route and let the user know that they should be attentive and they should use their own judgment. Maybe this map hasn't been updated for 2 years and we see that you're heading towards a lake. Maybe you should pay attention to your phone, or whatever, or pay attention to the road. So in total, we have here these 3 separate but related issues that all revolve around user trust, and we need to address those. So we have, to kind of recap, we have the back and forth, give and take nature of how learning works. We have the risk of a user placing too much trust in the system, and we have the risk of inaccurate predictions. So the question becomes, how do we mitigate this? So fear not, because these 3 complications can at least be partially addressed by changing how we approach designing a user experience. So for the designers that are listening in, you would probably nod your heads at this. Typically we would think that a user experience would be designed to be as smooth and satisfying and delightful as possible, right? Typically it's our job to remove friction, to boost completion or uptake or conversion, to get the user, through the flow real fast. We see this in e-commerce all the time. But in the case of AI products, it's almost counterintuitive, but it's actually really important to create room for mistakes, because those mistakes are your feedback. Those mistakes are how your system is going to learn. So both parties, the human and the machine, need to have that opportunity to learn how to work together and collaborate in order to augment the user's abilities, which is the whole point of AI, right? And again, we go back to this concept of, UX isn't about absolutes. It's never going to be 100% perfect. We're here to maximize the outcome for everyone involved, right? And so that's going to take collaboration, and collaboration between the user and the AI. And that's going to require mutual trust, which kind of seems silly to hear at first, but it's really true. And that's why we need to embrace the occasional mistakes of AI, to pull back the wizard's curtain, to, I guess, kind of show how the sausage is made. I mean, think about it this way, comparing AI to people again. And most of us really, we have a good concept of the strengths and the weaknesses of the people that we love and trust the most. People who we trust because we know what they're capable of, good and bad. And so the same should be possible for a relationship between humans and AI systems. And so we get there, in my experience, by designing for fault tolerance. Fault tolerant UX allows us to calibrate the user's trust in the system up or down as needed, depending on the situation, right? Sometimes we might want a user to trust the AI less or to trust it more, depending on what the intended outcome is. But at the end of the day, all of these use cases or different ways for us to elevate the user's trust, they're all based on this idea of honest, transparent design. So to that point, I kind of want to run through just a few design patterns that help promote fault-tolerant UX when designing for AI. So this is obviously by no means an exhaustive list, but I do want to showcase a few examples that many of you probably recognize from the real world, things that you've seen every day and maybe didn't realize that AI was involved, or if you did, maybe you didn't realize the benefit that you're gaining from AI acting this way. So one of my favorite methods when designing for AI is simulations. And simulations are a method that's commonly used in, for example, navigation software or predictive financial software. And what it does is it gives the user the possibility to play around with the parameters to see how the possible predictions of an AI would come out. So by moving around these parameters, the user learns how the AI and how its predictions behave, how they react under different circumstances. This is super useful when a user wants to weigh the pros and cons of different outcomes, for example, before they're making a decision. So by kind of letting the user retain a little bit of power in this situation, by allowing them to become fully familiar with the system with less risk involved, without commitment, kind of in a sandbox environment, it can really, really boost the trust, right? Because now the user understands the capabilities of the system. So when we're designing for AI, try to keep in mind that it could potentially be really useful to build in, kind of these simulation tools. If you are modeling, what future forecasts for retirement funds look like, allow the person to play with a lot of the parameters to see how you're making those calculations and to see what they can do to change those outcomes. It'll really build trust. So in a similar fashion, we have another method called the two minds method. And the two minds method, what this means is that both sides of a prediction are clearly communicated. Now, there's a certain confidence that a prediction is right, but just as much a certain confidence that it is not right. And so this actually becomes really useful when the result of an incorrect prediction could have significant impact or create safety issues. For example, when it comes to medical diagnoses, it's almost like the AI interface is saying to you that, hey, it might be this, but it might also be something else that we're really actively trying to avoid. So I would really like, your human judgment on this question. Again, in terms of building trust, this helps put the user at ease that the system is actively watching out for, even the possible predictions with a negative impact. The last thing that we want is, a doctor, for example, to assume that, this 95% certainty completely rules out the 5% that could prove very dangerous or fatal. So by kind of revealing that uncertainty, it's actually hugely beneficial depending on the circumstance that you're in. The next method, probably, very, very simple, obviously, but it's probably overlooked. And I think that, there's probably a lot of people that don't realize the depth of AI that's going on here. So option affordance is a design pattern or a thing that we can do that can really affect not only the trust levels, the transparency of a design, but also make a design obviously far easier to use. There's huge usability lifts here. You probably all recognize this from type ahead or predictive search. Basically, even when the AI is super confident about one result, it's sometimes good to offer multiple predictions to the user. It allows them to consider a handful of options and use their judgment before taking action, which, again, this is a concept that we're seeing repeated here, right? It also says, look, I've considered multiple options, and I really think this is the best path, but here's all the other ones I've considered, though, just in case I'm wrong. And so what we're doing here by affording options is, again, not only reinforcing the concept that the AI, really it knows what it's talking about, it's doing its due diligence, it's got all these, these possible matches, but it's also, to a certain extent, making it easier from a usability standpoint, in that, if, for example, you're searching for UX books, we don't want to just return UX design here. But, by giving all of these options, we're placing the user a single click away from what is actually the right result. So by building in that kind of fault tolerance, we're allowing the user to retain control, right? They are feeling more empowered, and they trust the system more because they feel more in control of it. They're getting a lot more information than they probably need, but that's good because that's giving them a choice as to what they need, what they can use. And in a similar fashion, nearest neighbor. So we see nearest neighbor models a lot in recommendation engines. So when the AI presents its predictions or recommendations in a certain order, say for like most relevant search results or whatever, it can be really interesting to show the close but not quite results. In the retail world, for example, timely and meaningful, like cross-sell and upsell opportunities of related items can do wonders for lifting your average order value. And there are definitely practical applications for this. But even in a general sense, this again indicates that what the AI was looking at and kind of indicates its thought process, where it's like, this item is definitely the most similar recommendation, but it also reminds me of other things that I've learned before in the past. And I think these items might be related. Here are the other items in case you need them. So, building recommendations like this isn't just about, driving more sales or at the end of the day, obviously, we're all focused on profit. If we work for business, the goal is to make money. But from the user standpoint, all of these kind of tips, this kind of fault tolerance way of thinking about teaching an AI, building interfaces that allow the user to correct the AI, to offer suggestions or to look at other alternate solutions. These concepts are hugely important for really maximizing the success and enabling that AI to help the user. And again, this is by no means an exhaustive list of anything. These are just food for thoughts and things to think about. If you remember nothing else from this, remember that machine learning mimics the human mind. The learning process for AI is very similar to the learning process of people. So it relies heavily on collaboration to learn and develop more accurate predictions. So as designers, as developers, as product owners and managers, the more that we can do to design these affordances into our products, where we can enable collaboration back and forth between user and machine, the better the experience is going to be for the user, but it's also going to result in more accurate predictions, right? By allowing your AI to make mistakes and allowing your teachers or your users to teach, what those mistakes are to the AI. Like a kid, that AI is gonna learn its lessons and it's gonna become smarter over time. So in order to do that, we need to create space for collaboration in our designs. That again, that feedback is crucial for improving the model. So if you're working on a project and you are designing something that leverages AI, whether it's an internal tool that you've built that maybe isn't mature, or maybe you're onboarding a vendor, some kind of outside solution that has a fully mature, bolt-on, AI solution for something, whether it's retail, e-commerce, or finance, or health, whatever it is, kind of making sure that as you're designing, you are keeping in the back of your head that this system that you're interacting with, no matter what it is, it's a thing that's learning. It's a thing that needs help, right? So anything that we can do to design features into our products to allow our users to give that feedback to the system, we should be doing that. And along the way, admitting when our model might be wrong really helps mitigate automation bias. If we can tell a user, yes, this prediction has an 85% certainty, and this prediction, is only 35%, kind of unveiling that level of trust, internal to the AI can help make people trust it more too. They don't see the AI as being this infallible, black box of magical answers that gets everything right. They learn to work within those boundaries and those confines, and that helps them do better work. That helps them do faster work. They understand the system more. So don't hesitate to be honest about what you're making. Don't try to treat artificial intelligence as though it's this, end all be all, fount of truth and knowledge, and you kind of, your design places it up on a pedestal. That's not necessarily the right thing to do. Maybe it's being honest and being transparent about what you or your system doesn't know or can't do. Maybe that's the best course of action. We know that from firsthand experience, building AI systems that collaborate closely with their users leads to a better user experience. It nurtures that trust in the product. It's important to have guardrails around that trust, but showing those boundaries of capabilities, asking for feedback or confirmation, adding context when it's necessary, or even giving the user to kind of play around and simulate different scenarios. All of that involves the user more with the AI system. They become excited to try out and explore future possibilities. Designing a fault-tolerant user experience really means that you're going to hopefully prevent accidents and dangerous situations, that your product or service is going to provide more value to its users. So, at the end of the day, just keep in mind that intentionally designing collaborative AI, instead of making them easy to use or as smooth as possible, can really maximize the user's experience and ensure that we are leveraging AI the way it should be, right? I think it's time to really start having honest conversations between ourselves as designers, along with conversations, that probably need to be had in some shape or form between users and machines, so that we can start facilitating that designing with purpose and addressing those needs and really augmenting people's capabilities with AI. It's a really exciting future right now. I just hope that it turns into a future where less people are driving into lakes. So yeah, that's all that I had. Hopefully you guys all took something out of this. I didn't know what to provide going into this, so I tried to keep it, approachable and accessible to, not just designers. So I didn't know if we had any questions or Q&A or anything, but